for Gen AI and larger workloads, we are going to see more and more pressure on our existing networks as enterprises. We're going to see performance challenges. We're going to see longer processing times, new threats coming up, especially with AI, with the black box models. We really don't know what they carry. A lot of emphasis on the open source predictive AI models, a lot of emphasis on open source Gen AI models. We don't know where they get injected with what. So there's going to be a big, larger scope on the threats. Now, what do I recommend? I recommend that at this point of time where network leaders are looking forward to the changing demands of the consumer, of their own businesses, on the use cases, I recommend them to relook at their foundations. And at the base of the foundation is our network architecture. Because if we have a very optimal network architecture, scaling that architecture becomes very easy. Scaling that architecture would mean adding newer components that can easily be integrated in your existing existing architecture, and uh, you know it's important when we are relooking at these architectures, we are also relooking it from the security perspective with zero trust. And as we implement that, we also augment all of that with automation and AI. We're going to talk more about it, a little bit more about it in the further slides, but this is how I look at the future direction, or setting the foundations for that future direction. So it wouldn't be an overstatement if I said that in 2025, network automation and AI tools, along with an optimal architecture, will not only be a luxury, but a necessity that most of the network leaders or most of the technology leaders have to look at. Taking a pause there and moving on to my next slide. So in this slide, I just wanted to touch base a little bit on what all of us have seen in last 10 years, what all of us have seen happening in last 10 years. We all know in 2010, we had IPv6 adoption happening, and it continued through 2020s as well. But that's the pivotal point where we were able to get larger IP addresses, spaces, and improved network capabilities to deal with most of our networking needs. It was further augmented by, in 2024 to 2016, we saw LPWAN kind of technologies come up, which was low power wide area network that actually helped us expand to the wider areas and yet have the low power consumption, because at the end of the day, when you run your data centers, when you run all of these high load networks, you have to think about the cost savings, and that's what low power consumption helped. And this also helped us connect to Internet of Things, which is all of your internet devices, your mobile phones, your many other devices that are network enabled, and pretty much a lot of this stuff at homes is network enabled now. So all of that saw a lot of growth in 2014 to 2016. Somewhere around 2015 to 2017, we had SDNs and NFVs. Again, shaping the future for cloud. We had NFVs, a lot more virtualization happening, and SDNs expanding and decoupling a lot of our software from the hardware. Going to 2017 to 2020, and one point I want to insert is that all of these technology advancements were actually helping set a base for the next wave of advancements. Because when I was putting this slide up together, and it actually gave me a chance to look at this evolution and made me realize that none of it was actually in silos. Everything that happened as a part of the advancement had something prior to it asking it to happen, and something in the future where these technologies were setting and filling up those gaps.